My name's Camille, and today I want to briefly introduce myself as a researcher, as well as talk to you a little bit about some of the work that I've been doing, thinking about how we can use marine top predators as observing platforms and sentinels of climate change. Walter Munk, one of the Einstein of the oceans, coined the 20th century as the century of undersampling in the ocean. But since the year 2000, we've sampled more than the previous 100 years. And this is really thanks to great advances in instrumentation, specifically autonomous instrumentation like the Argo profiling flow. And I'd like to add that advances are also coming with new data analysis methods. And so I have three overarching themes in my research. The first is on building low-cost technology with the goal of democratizing access to the ocean. The second is on building detection, classification, and localization tools for passive acoustic data. And lastly, the third theme that I'm going to talk about today a little bit is about using animals as an ocean observing platform. So I'm hoping in the next 14-ish minutes to talk about two stories, one about sharks as oceanographers, and the second about a single tag that collected data on a tuna for 6 years. And I want to give a beware because we are exiting the tropical Pacific. I know that was part of the theme, but I'm breaking that. But hopefully the lessons that you learn from this data, you can think of how you would apply them here. All right, let's see if this goes. Well, maybe it won't play. But since the mid-90s, animals have been tagged by biologists, and what should show up here is nice different colors showing tracks of animals departing the California current. And these tags don't only measure position, but also temperature and depth. So I've been thinking about these animals as more of an oceanographer, thinking, well, they collect temperature and depth along their tracks. Can we use them to learn more about the ocean? And I was fortunate to have access to the first CTD tag, conductivity, temperature, and depth, that measured temperature and salinity, that was equipped on a shark. And this shark is a salmon shark, and the map you're seeing here is a subset of the Gulf of Alaska. And so the shark collected 56 profiles over 36 days, right at the end of the marine heat wave known as the blob in August and September 2015. And most oceanographers in this room might not be too impressed with the temperature salinity data that's there because it's data that we typically see. And so I was curious, where do these 56 profiles stand amongst the ocean observing network? And when I went to the World Ocean Database, all these black dots are only 119 additional profiles that were collected on days during that 36-day period. And of those 119, only 2 were co-located with the data collected by the sharks, but they were 1 day apart, which, okay, temporally, but spatially 0.75 degrees of latitude and longitude was as I had to expand pretty far to find co-located profiles. And the data looks fairly similar to the Argo profiling photos. The sharks, which are the colored profiles here, only have 16 points in depth space, so they're a little bit cruder. And then you can see that the top panel, the shark was actually in an eddy, so you can see that mixed layer depth extending deeper than the Argo profiling float that was closest nearby. So what did we learn from this shark? During its trajectory over 36 days, it went through 7 mesoscale eddies. And we took the temperature and salinity data, which was fairly patchy, but we had good location to assign these in space and calculated anomalies. So that's what you're seeing is the top panel temperature anomalies, the bottom panel salinity anomalies. And I want to zoom in on when the shark was in one of these eddies, an anticyclonic eddy. And what we can see is that this region in the Gulf of Alaska has a characteristic cold and fresh cap at the surface that's been subducted by the blob in the top 15 meters. And this aligns well with other observations from traditional platforms. And as the shark kept swimming, it went into a period where there was higher and large positive anomalies of surface of salinity, and I thought the sensor was broken until I pulled up a sea surface salinity anomaly map to see that it actually was in a plume from the offshore pool of water, and there was no other in-situ sensors in that area, so it hadn't been reported that that plume had gone to the coast. So you could see things that traditional sensors were not there, so this shark has a unique observation that actually makes sense when you bring in this satellite data. But this is an N of 1, and that's going to be a theme here, great N's of 1. And so what can you do with an N of 1? Well, you can pretend if you had a whole bunch of these sharks, and these are tracks from 116 sharks in that same area. What if these sharks had been instrumented with a CTD tag? And so this is assuming that the shark collects approximately 2 profiles a day. That's at minimum. The shark could potentially transmit more than 1 profile a day. And if I take those tracks, they are generating around 509 per year. This is, obviously the math doesn't scale up because of some of these tracks are shorter or longer of deployment length. And you could collect 18,000 profiles. During that same time when sharks were present, Argo profiling floats, which collect a max of 36 per year, collected around 8,000 profiles. And the key thing here is these sharks are actually collecting data at sub-mesoscale resolution. And so the closest analogy I can find for a shark is that of a glider. And so when a glider does its trajectory up and down, over the same time, a shark is collecting a profile every about 120 meters and every 36 minutes, so collecting a lot more profiles along the way than a glider. And so if you take all of the platforms available in the World Ocean Database, you nearly double the amount if you instrumented 116 sharks. So sharks could be great oceanographers, we just need to give them the toolkit to do it. This shark collected data during the blob, a marine heat wave, and unfortunately marine heat waves are becoming more prevalent and have occurred around the world. And so I'm going to jump from the Pacific over to the Atlantic to ask my next question, as whether animals could be sentinels of climate change, whether we can see adjustments in their behavior, both where they go and vertically, that tell us, hey, these animals are the ocean is changing. And if you look at the literature, there is tons of examples of animals that are tagged shifting northward. And that's pretty much the take-home message of all of these. But all of these are based on tags that were deployed on for a single year on an individual. So they don't consider individual variability, physiology, or ontogeny, or just their general personalities of where they might like to go. We are lucky that one tag stayed in a fish and collected data. Let's see, it's not gonna go. So I'll just go to here for almost 6 years. So this collected position, depth, water temperature, as well as body temperature data for 1,936 days. And so as the fish grew and swam around the ocean, it experienced 2 marine heat waves in the Northwest Atlantic, one in 2012 and one near the end of 2015 to 2016. So having 6 years kind of gives us somewhat of a before and after to see whether this animal is reacting. So what happened in 2012? Well, this is the year the fish was tagged, and the fish did what we see typical of Atlantic bluefin tuna that are tagged off the coast of North Carolina. It went to the Gulf of St. Lawrence. So we were like, okay, it did what it was supposed to. So what did it do the following year? Well, it decided to go on a little adventure all the way across the Atlantic up to the Faroe Islands. And so if you see this, your instinct might be to think of why. Well, these northern latitude waters were warmer, so maybe this smaller fish can now access that region where larger tuna are occurring. And I am sorry that I didn't put this in here, but you'll have to believe me when I say, if you just showed me 2013 and didn't show me 2012, I wouldn't think that anything was weird. Because sometimes the tuna that we tag on the coast here go on a little adventure and do that exact pattern. So is that a response to the marine heat wave, or did it just want it to go to the Faroe Islands for fun? So after 2013, it eventually comes back in 2014 into the Gulf of St. Lawrence. And then in 2015 and 2016, it does a very similar pattern during the marine heat wave experiences. In both years, it's in the Gulf of St. Lawrence, and that's similar to what it did in 2012. So I was like, okay, not really interesting. But if 2013 was a response to a marine heat wave, I'd think after these 2 years, in 2017, the fish would do something crazy again. And so in 2017, if you look at the dark blue dots and light dots, you can see the fish is starting to go north, and then it decides to come back to the coast, go south, and eventually go into the Med. And for Atlantic bluefin tuna, going into the Med is thought to be for spawning. If you enter the Med, you're going to spawn. And so is this just, oh, it was time to go spawn, and I started going somewhere, and I have to go back and do this pattern, or is this a response to a marine heat wave? So in addition to this almost 6 years of position data, there was nearly 6 years of vertical data of depth and temperature. 2013, which is now highlighted in red, is again a weird year compared to all the other years, because it wasn't in the Gulf of St. Lawrence when it was supposed to be. And if you look at it, its daily maximum depth was deeper, the time it spent in the mesopelagic was higher, but the temperatures it experienced at those northern latitudes was actually very similar to what was in the Gulf of St. Lawrence. And tuna are known to associate their diving behavior with the mixed layer depth. So the mixed layer depth was deeper there, so maybe these tuna were just diving deeper. And so it's a reaction to a local condition. And teasing out the differences between a response to marine heat wave versus a response to what the conditions are and it's experiencing in that time are super hard, even when you have 6 years. There's a lot of cool stories with this fish. We can see the development of endothermy. And when we look specifically at the Gulf of St. Lawrence, turns out even in 2014, when there wasn't a marine heat wave, it did the same thing across all of the 4 years it was there. So we tested nearly everything you could think of, and there was no difference. So just to wrap up, some takeaway messages. So for the physical oceanographers in the room, I want to say that animals as ocean observing platforms can provide you an immense amount of data. If you are complaining that you don't have enough data to put into your ocean model, there is lots of temperature and depth data that has been collected by animals. You might just have to accept that it wasn't from a CTD that you got to control. And so there's some uncertainty that comes with that. For the biologists in the room who want to predict what animals might be doing in response to marine heat waves or other climatic events, I encourage you to think about individual variability and just biologically natural patterns, because I don't know if 2013 was just it went on an adventure that other fish have shown to do in non-responses to marine heat waves, or if it was truly a response of, I want to get out of Dodge because it was too warm and I'm going north. Physiology and ontogeny was 2017. We kind of saw the start of it going north, but it decided it needed to spawn. So teasing these things out in addition to shifts both in horizontal and vertical space, and doing all of that is difficult, so best of luck to everyone trying to do that. And finally, to get it back to the Pacific, if you're interested in animal tagging data, this is from the Animal Telemetry Network, and there is a lot of data in the Pacific, specifically the North Pacific, and hopefully there'll be more in the tropical Pacific in the future.